Alright, so I'm going to go through the math test, math unit 1. So we began with the first problem, 3 plus 2 to the second power times 9. And it's important to, I think, to write out the problems, and so this is a good habit of carefulness. So when I'm looking at this problem, any kind of expression, I'm always going to think about the order of operations. And so you can use the acronym or the, not acronym, the mnemonic PEMDAS. That stands for parentheses, exponents, multiplication, division, and then addition and subtraction. Okay, so there's no parentheses in this problem. So next is exponents. The first thing I want to do is the exponent. So 2 to the second power is the same as 2 times 2. So I'm going to write that out down below to make it clear what I'm thinking. And then I'm going to go ahead and rewrite the rest of the problem. 3 plus 2 times 2 times 9. Okay. I need to do that 2 times 2 first, so I'm going to go ahead and simplify that to 4. So now I have 3 plus 4 times 9. And some people went left to right. If I do that, I'm going to get the wrong answer. Because according to PEMDAS, after exponents, I need to do multiplication and division. That means I need to do 4 times 9 first. Okay? 4 times 9 is 36. So now I have 3 plus 36. And I get an answer of 39. Okay? If I don't do that, okay? So if instead I did 3 plus 4 times 9. So if I do the addition first, watch what happens. 3 plus 4 is 7 times 9. I get 69. Okay? But that is the wrong answer. Even though I did my arithmetic correctly, I didn't follow the order of operations, and so that is the wrong answer. Okay. So order of operations really makes a difference, and moving forward, that's something that you're going to expected to know. All right. So second problem, I actually made a mistake on the test, and so I didn't have the right answer there. So everyone got that right, regardless of what answer you got. But this is still good to review. So 2 times 3 to the second power minus 5 plus 2 times 3. Okay, so going to parentheses first. I'm going to start with the parentheses, but now within the parentheses, I also have to follow PEMDAS. So within the parentheses, I've got an addition problem and a multiplication problem. Following PEMDAS, I'm going to do multiplication first. So 2 times 3 is 6. So I have 5 plus 6, and that is 11. Okay. Now I can rewrite the rest of the problem. 2 times 3 squared minus 11. Okay. So now I'm going to do my following PEMDAS. I'm going to do exponents first. So 3 squared, that's the same as 3 times 3. And now I have 2 times 3 minus 11. So that is 2 times 9 minus 11. Here I'm going to follow the order of operations. What do I do first? Multiplication. So 2 times 9 is 18 minus 11. And that gives me an answer of 7. So on the test, I made a error and I put 6, and I thought that was the right answer because I was making a careless error when I made my test. So I apologize for that. But the correct answer is 7, and congratulations to those of you who got that and couldn't find the right answer in the test. You were right. All right, so problem number 3. We have 5 times 10 to the 3 and plus 6 times 10 squared. Okay, so here looking at this, I have two parentheses, and I have, within that, I have exponents. So I'm going to solve each of these separately and then add them together. First thing we want to do in the parentheses is the exponents. So this first one is same as 5 times 10 times 10 times 10. Make sure that you are multiplying the tens with exponents and not adding. So the second one, it's going to be 6 times 10 times 10. I would highly recommend writing it out like this. It's a good way to keep track and not get confused. Okay, once we have 10 times 10 times 10, I can just change that to what it would be. So 10 times 10 is 100. 100 times 10 is 1,000. So here I have 5 times 1,000 plus 6 times, and 10 times 10 is 100. 6 times 100. Okay. 5 times 1,000 is 5,000. And 6 times 100 is 600. So add that together. I should have 5,600. It's a good habit to put your commas in the right place and not get confused with that. So 5,600 or 5,600 is the correct answer. All right, so next problem, it says find the value of 2.99 times 10 squared. Okay, so this would be the same as multiplication. Okay, same thing I want to do. I want to do the exponents first. 10 times 10 is 100. So this is 2.99 times 100. Okay, and here I find this helpful to use a place value chart. Okay, let's go ahead and put the decimal point in there. Okay, so if I had 2.99 and I want to move that over 100, that means I want to move it over 2 spaces. Okay, so that means I would have the 2 over here, the 9 goes over 2 spaces, and the other 9 goes over 2 spaces, and I end up with 299. Okay, remember that every time I move to the left, I'm going times 10. So if it's times 100, it's to the left 2 spaces. All right, the next number is, or the next problem was 39,860. And what is 10 times less? So here I'm going to think, where's the decimal point? The decimal point is right here. I could add on those extras. And in order to do 10 times less, I want to move all of these digits, or all of these numbers, over to the right 1 space. Well, instead of rewriting all the numbers, another thing I can do is I could take my place value, the decimal, and just move it over 1 to the left. Okay, so then I would end up with 3986, and then the decimal point. Okay, so once the decimal is there, I don't have any zeros left over, so I don't really need the decimal point. I'm just going to add a comma in the right spot. Okay, and that is the correct answer. 3,986 is 10 times less than 39,860. So, next problem. What number is 100 times greater than 1299? So we want times 100. Okay. Here I want to move these numbers over to the left compared to the place value point. Okay. So if I did it 10 times bigger, it would be 129.90. That would be 10 times bigger. And 100 times bigger would be 1,299.00. And that is 100 times bigger. All right, next problem is a multiplication problem. It says 3 scientists each had 465 pieces of matter. Okay, so this is a basic multiplication problem. I'm going to create an area model here. 3 times 400 plus 60 plus 5. And once I break it apart like that into its exponential form, or its, expanded form, not exponential, expanded form, it becomes much easier to do. So 3 times 400, I'm going to do 3 times 4 is 12. 3 times 400 is 1200. Okay. 3 times 60, I'm going to think 3 times 6 is 18. 3 times 60 is 180. 3 times 5 is 15. Now all I need to do is add those together. So 1200 plus 180 plus 15. And I get 1395, or 1,395. Could also solve that another way. So we could use the standard algorithm. Make sure I've copied down the problem right. Oops, I didn't. Found my mistake. Glad I checked. All right, so I'm going to start with 3 times 5 is 15. I'm going to go ahead and break that 15 into tens and ones and put the tens up there, regroup the tens. Now I'm going to multiply the tens. So 3 times 6 is 18. I'm going to add the other 10 in for 19 tens. I'm going to put the 9 tens down here and put the 10 tens up here. So I'm regrouping the tens. And now I can multiply the hundreds. 3 times 400, 3 times 4 is 12, plus 1 more 100 is 13. And I get the same answer. It's just a little faster, and I do the adding together. So great. Definitely you want to keep on practicing the standard algorithm if that's not familiar to you.